Our next speaker is focused on lending, cryptocurrencies, and urban policy. She's an investor at Bloom and is speaking to us today about Webpack and Ethereum smart contracts with TypeScript. Ladies and gentlemen, please welcome to the stage Devon Zuegel.
Hello. Looks like my slides are working. Cool. Alrighty. Hi. My name is Devon, and I'm an engineer and rater based out of San Francisco. 7 months ago, a cryptocurrency project called Rex LMS lost $6 million worth of Ethereum. The root cause was a single line of code. Unfortunately, this wasn't an isolated incident. Smart contracts are notoriously buggy, and the cost of a mistake can run in the millions of dollars. Another tool that is notoriously hard to debug is Webpack. Seems like some of you guys have experienced this firsthand. People often describe working with Webpack as taming or wrangling it, and I think those are pretty fitting verbs. Webpack is extraordinarily flexible and powerful, but as a result is also super complicated. It's one of its biggest strengths, but also its biggest weakness. Today, I'm going to talk to you about how TypeScript makes integrating both Ethereum smart contracts and Webpack much more robust, maintainable, and fun. Let's start with Webpack. More people here are probably familiar with it, and it sounds like you guys have had the pain firsthand. I spend a lot of my free time working on small side projects for myself and for my friends, but about a year ago, I realized that I was spending most of that time just dealing with Webpack, which is not fun. I asked myself, what the hell are you doing, Devon? This is supposed to be your free time, and you're just dealing with config files. Let's not do that. I wanted to be building cool stuff. I started poking around for solutions, and there was an endless supply of Medium posts complaining about Webpack not doing what they expect, having very little meaningful output when things go wrong, and allowing things that seem that they shouldn't be allowed, but they weirdly are. There are a lot of challenges with Webpack. One issue is that there are many ways to represent the same thing. To take just one example, Webpack's loaders interface is extremely permissive. A loader can be a string of just a name, a string with query params, an object containing a bunch of options. Sometimes it's called a query and not options for no apparent reason. You can have preloaders, you can have postloaders, you can have keys named loaders, plural, or loader, singular, or use, because why not? You'll notice that this image of the gist up here takes up the whole slide and had to go past the header. That's because it is just a small sliver of the complexity of Webpack and just one piece of it. I could go on. There are many ways to get the effect that you want, and some ways are more correct than others. This is overwhelming for a newcomer, and it can lead to frustrating bugs for anyone. Another issue is that Webpack has very opaque error messages. Sometimes it doesn't have error messages at all, and it just doesn't work. It's really hard to track down bugs when your config is the only constraint enforced in your config is that it's a JavaScript object. A shocking number of Stack Overflow answers boil down to, I think you just have a typo. This is just the tip of the iceberg with issues that you can run into. Another issue is that it's really easy to use old syntax. Webpack is currently on version 4, and it has gone through 4 versions in the last 6 years. On one hand, this is great. It means that Webpack is improving really rapidly, it's changing quickly, it's adding new features, but it also means that you have to keep up to date with those features, and that's a pain in the ass. The old loader configuration is a good example of this. It was superseded by a more powerful rules system, which allows configuration of loaders and more. But for compatibility, the old syntax is also still supported. And so it's very easy to find documentation with the old syntax without realizing that it's referring to an older version. And also, just accidentally use it yourself because there's nothing that stops you from doing so. It's not possible anymore to omit the loader extension without referencing the loaders, but actually it still sometimes is because they realize that it has to be backwards compatible and they're going to break the web if they don't do that. So both it enforces things and not at the same time, and you end up mixing and matching lots of old versions. This is just the tip of the iceberg. If you take a look at this list, and you'll notice it goes off the page, it includes all of the changes that you have to keep in mind when you are transitioning to a different version. There is a lot of them, and frankly, no one has time for that. You have better things to do. You want to build cool stuff. Finally, Webpack has a lack of sensible defaults. It's really hard to get started if you've never built anything before. I'll tell you a little secret. I usually just copy and paste my old Webpack config from old projects, and then I just like fiddle around with it a little bit until it works, which inevitably means that there's a lot of useless garbage in my config that is going to confuse the next person who comes along. And I'd really rather be able to start from scratch without having to go through all of the pain that I already went through. So if you extract Webpack out of this conversation, these are the obvious problems you run into if you're not using a type system. Types solve all of the problems that I just listed. So each of these areas present serious challenges, but they're also emblematic of Webpack's greatest strength, is flexibility. I wouldn't want Webpack to remove any of this complexity, actually, because then it would not be as powerful of a tool, and I'd be using something else. So I've been really happy to be able to bring TypeScript into the way that I do Webpack, because that allows me to both get all of the value of the flexibility while also not being confused. You can imagine my delight that when I discovered that I was wrong, that you can actually use TypeScript. I was going through the world writing all of my source code in TypeScript, but I was still stuck with an old JavaScript file for my config, just because I didn't see anywhere in the documentation that there was a solution here. But I poked around in the source code a little bit, and if you look closely, you don't have to read all the code, but if you look closely, it kind of gives you a hint that maybe this does support other types of files. It doesn't say you can't use TypeScript. And so I looked around a little bit more, and I realized that it's actually super easy to incorporate TypeScript into your Webpack config. We don't need to dive into here. I'm going to include links to these slides later, so no need to write all this down. But basically, it's as simple as just adding TS node as a dependency, changing your extension, and then just running Webpack as you normally would. It's really trivial. Since I first did this talk, Webpack has actually added this to their documentation, thank goodness, but originally it was not in there. So you can do more than those changes to make it even more powerful, but just with those tiny changes, you'll immediately see the benefits. The type definitions for Webpack are fantastic, and you get these for free. So let's take this small example. For those familiar with Webpack, you'll see that the line where output is defined is slightly wrong, but not obviously wrong. And to someone who's new, it could look valid. JavaScript's not going to tell you that. It's just going to silently fail. So my old MO was that I would Google terms. And these terms tend to be very overloaded. They're terms like resolve or module, which mean a lot of things in programming land, and they actually mean a lot of things outside of programming land too. And so you end up getting a lot of irrelevant or outdated results. When you have types, those options are exposed right to you in your text editor, and you don't even have to Google in the first place. You stay inside of your editor the whole time. Better yet, it explains to you what you've done wrong. If you want visibility on what's going on under the covers, you can use go-to-definition to jump right to the location in the definition file. I've used this a million times, and it has completely transformed the way that I code. So the other thing that TypeScript brings you with Webpack is that it effectively brings documentation to you right in your text editor. Examples and tutorials are invaluable, of course. It's how a lot of us here learned how to program. But the real challenge of Webpack comes whenever you're doing something custom. The official docs can only enumerate so many of the permutations and config options. The type definition files have the added advantage of allowing you to stay within your text editor. These tools allow you to discover answers latent in the type definitions when before you would have to hunt them down. On top of all this, the documentation provided by the types don't go stale. Now, this is my favorite part of using TypeScripts with the Webpack config. Not only will it tell you what you're doing wrong and stop you from going down the wrong path before you do it, you can also constrain the interface to exactly what you need. This allows you to communicate what you're trying to do to future developers, which include yourself, and it makes it much easier to follow conventions that you set ahead of time. So if you take a look here, actually, we'll go back a slide. So here, you can see that there's something called old module and new module. And where these come from is that in Webpack version 1, there was a sort of crappy definition for module. And they ended up updating it and fixing it and making it way better. And so it's called new module. You want to use new module if you can. The thing is that it's the basic TypeScript definitions will let you use either one because of that backwards compatibility I mentioned early on. And again, this is a gift that they've given us because they don't want to break our code. But if you know what you're doing, and if you know that you are only using the new modules, you can enforce that so that moving forward, all developers on your project only use that one. So what you can do moving forward is you can specify your own custom type for your config where you specify that you're using the new module. This is also powerful in creating these like guide rails that you can work with, and you end up only building the things that you need. And when someone adds a whole new thing that's not supported by your type, then that person does it very consciously, and they have to manually go into the types to update it, which sounds kind of like a pain in the butt, and maybe it is a little bit, but it's better than having a bunch of junior devs adding stuff all over the place, and then you having to clean it up later. So, to wrap that up, Webpack used to be a nightmare for me, and now I spend almost no time on it. That's not because it's a less important part of my workflow. It's actually more important now. But the problems that I ran into are basically gone, and so now I get to build fun stuff without having to deal with a bunch of configuration files. So, at work, I work at a small crypto company called Bloom. And at work, I've been writing and interacting with Ethereum smart contracts. Seems pretty different, and it is. The problems that I'm running into at work, though, feel really similar to the ones that I had with Webpack a little over a year ago. The tools in this space are super nascent. There are almost no error messages at all. And so when I realized that I was having this similar level of frustration, it kind of turned on a light bulb in my head, and I realized, man, types would be super useful here too. Last time I was this annoyed with programming, I was wrangling Webpack. Integrating with smart contracts can be tough. In particular, Solidity, which is the language that you write Ethereum smart contracts in, doesn't really have runtime errors with the descriptive messages, so a lot of failed transactions just fail with the generic message invalid opcode. That is the only error message that you get. It's really painful. Writing tests for smart contracts can be especially tough. And tests are really important, especially when you're dealing with millions of dollars that are flowing through the system. In the example video, I'm trying to test the buy tokens function, and I make a series of mistakes along the way. The test output usually tells me that there's something wrong, because I'm writing the tests to confirm the output, but it doesn't really tell me what's wrong. It just yells at me and is like, I don't know what's going wrong. The thing is, if it's painful to write tests, you're probably going to write fewer, and you're probably going to lose a lot of money. At Bloom, we want to do our best to build reliable contracts, so we looked for strategies to reduce this testing pain and the overall pain. There are several mistakes in the code that I was showing you before. One of them is that you don't put amount 50, you should have value 50, which is really important if you're sending money. You're calling a function called balance of on a sale contract instead of a token contract. We forgot to wait for the promise to resolve, which is an issue that you get all the time in JavaScript land. And we sent ether to a non-payable function. So at best, that failed. At worst, you just sent money into the void, which is really bad. The crazy thing is that we have the technology. When you compile your Solidity contracts, you get what's called an ABI, and you don't really need to know exactly what that is, but basically it's a JSON representation of the contract that tells you what the functions expect. They have all of the type information. They tell you what arguments you want to pass in and everything. They're just not plugged into our editor. And so they don't really stop you from doing anything wrong. They're just there sort of as lame documentation. The cool thing is that we can translate these into TypeScript typings. If you look at that slide, you can see how we manually went through for our original spike, and we took our ABIs and we turned them into the typings, which is a pretty tedious process, but 100% worth it. And now we see a pretty big difference. Every mistake I had to make before, after seeing the test fail and watching them rerun and rerun, all of those were shown immediately to me in my text editor. Let's go through them one by one. So for one, it gives me a list of functions I can call on the sale, which sounds trivial, but it's actually pretty nice because then it just auto-completes. I'm preaching to the choir there. It tells me the arguments for buy tokens, so I start actually just passing things in immediately without having to look it up or transcribe stuff. It reminds me that the function returns a promise, which I need to wait for. And as we all know, JavaScript code is asynchronous, but JavaScript code that interacts with smart contracts is especially asynchronous. I don't know if you guys have read much about Ethereum and its performance issues, but it takes a really long time for everything to happen, like sometimes on the order of 5 minutes. So it's very important that you await. Now it'll also correct me when I type amount instead of value, when I specify how much ether to send, which is, again, really important because we don't want to send Ethereum into the void. It reminds me to change the sale to token for calling balance of. In the previous example, I was literally just calling the method on the wrong variable, which sounds dumb, but it's a really easy mistake to make. And finally, it points out that I cannot send ether to balance of. That's not a function that is actually sendable, and so I'm not allowed to specify the values as an option. So to dive in here, this is a really small example of that crypto project that I mentioned earlier, Rex MLS, that lost $6 million. I don't have access to their actual source code, but it must have looked something kind of like this. And the problem that they ran into was that well, actually, I'll back up a little bit. Ethereum addresses are hex strings. They start with 0x, and then they have a bunch of letters and characters and numbers after that. Pretty straightforward, right? Just an address. The problem is a hex string looks awful lot like a hex. Well, you can see in the commented outline above, there's also a hex string, which has the exact same characters, but it's not surrounded by quotes. And that's a very different value. The problem with this is that when you send money to the wrong Ethereum address, it's irreversible. And what's worse is you're actually not sending it to anybody. You're just sending it into the void. That money is gone forever. Ethereum's address space is massive. There are 2 to the 256 possible addresses, which means that the vast majority of them are not called for. And so you're not doing anyone any favors, you're just throwing that money away. Not only is it an expensive mistake to make, it's a really embarrassing mistake to make. With TypeScript, that would have been caught immediately. Not only would TypeScript have warned you, but it wouldn't have let the code compile in the first place. So this is what a $6 million mistake looks like. The intended address above is in black. That's what it looks like. But the one right below looks kind of similar. Like if you're doing a really quick sanity check and you're in a rush or something, you can be convinced that it's the same thing. But it's not. So if you go to this address on Etherscan, you can find the money just sitting there for anyone to see. And it looks really bad. So this is all great news. We can use TypeScript to catch mistakes that are expensive and embarrassing. But as I mentioned before, it's kind of annoying to write your own definitions files. Everyone knows this. It's sort of the annoying part of TypeScript. You don't want to have to write them yourself. The good news is that because our ABIs are very well structured, we can programmatically generate our type annotations from them. You can check out the repo that I have above. I also have that in my notes, so you can just copy down the link at the end of the presentation. But basically, one of my coworkers, John, built this really great tool that will programmatically generate your typings from the ABIs. And so it's actually painless to do this also. You have like no excuse not to do it. So the result of this is that if anyone out there sends money to the wrong hex address again, they really have no excuse. They should have just been using TypeScript and they wouldn't have made that mistake at all. So thanks very much. This is really fun talk, and I really hope that this gave you guys a sense of TypeScript's versatility. It's a really powerful tool, as we all know, that's why we're here, but it can also make the most painful parts of programming much easier when you're using external tools too. Probably the link you care most about is the one at the very top. It's the bit.ly link, and, bit.do. And you can find all the rest of the resources on that. And I'd love to keep in touch. If you guys have any ideas on how TypeScript can make other parts of programming less painful, please tell me. I will use it. So thanks very much, and it was fun talk.